All right, guys, welcome to chapter 13.5, graphing linear equations in standard form. What we are doing today, not too surprising, we are graphing and writing linear equations in standard form. Let's get that out of there. All right, so standard form is ax plus by equals c. This is a different form than slope-intercept form. Remember, slope-intercept form was y equals mx plus b, where we were given our slope and our y-intercept. Here, we are not straight off the bat given our slope or our y-intercept. We are given some number, we're calling that a, attached to the variable x, some number attached to y, we call that b, and then we have that random constant c. So it seems like that random constant c would be your y-intercept, but it's not, because you have to get rid of that b that's attached to the y, so it's compromised. That c is actually not your y-intercept because it will be divided by b. But we'll get to that later. So remember, slope-intercept form is y equals mx plus b. So what is standard form? Standard form, you can still graph using standard form. However, it's a lot more difficult. So for example, this line is 3x plus 5y equals 15. It's kind of weird, right? It doesn't seem like you would be able to write an equation or a line based on that equation, but you can. Another one, 2x plus 3y equals 6. That works. If you plug in those points, they will work. 3 times 0 is 0. 2 times 3 is 6, so 6 equals 6. 2 times 3 is 6. 2 times 0 is 0, so 6 equals 6. They work, right? So standard form, ax plus by equals c. Now, some things to note about ax plus by equals c. You can, for a can be any number. It does not matter what number it is. It could be a fraction. It could be a decimal. It could be a positive number. It could be a negative number. Same with b. It could be positive. It could be negative. It could be a fraction. It could be a decimal. It could be a whole number. But c could be a fraction. It could be a decimal. It could be a whole number. But c right here must be positive. This c right here is always positive in standard form. That is the important part of ax plus by equals c. So we will be doing some examples that are standard form, some that aren't exactly standard form, but they're close. But we're mostly going to be working with standard form today. So now, example 1. We want to graph using slope-intercept form. So we are going to be given this equation right here. This equation is standard form. 5x plus 4y equals 20. And we want to graph that. However, we cannot just graph that. I can't plug in a 5 and then give me to plug in 4. So what you can do, you can plug in numbers like 0, plug in 1, plug in 2, plug in 3, but that's not using slope-intercept form. So using slope-intercept form, we want to transform this equation right here into slope-intercept form, and then we want to graph it. So what we're going to do, we're first going to solve for y. We want to get this 4y by itself. So how we're going to do that, we're going to subtract 5x to both sides. So therefore, these cancel out, and we get 4y equals, now I want to line this up so that it's close to slope-intercept form. So I'm going to put minus 5x first, and then I'm going to put plus 20. I want you guys to notice right here, I did not put 15x. 20 minus 5x is not 15x. Those are not like terms. When you add or subtract, they must be like terms. Since these are not like terms, we leave them separate. Next, I need to get rid of this 4. So I'm going to divide both sides by 4. This gives me y equals, now minus 5x divided by 4, that does not go in evenly. So I'm just going to put minus 5x over 4 or minus 5 over 4x. And then 20 divided by 4 is 5. This is now my equation in slope-intercept form. I've transformed this. My slope, m equals negative 5 over 4, and my y-intercept equals 5. That means that I can graph this. I can go over to 5 right here, and then m is negative 5 over 4. So I'm going to go down 5 over 4. Now, I could go down 5 over 4 again, but it's not going to make a straight line, right? Or, sorry, it will make a straight line, but it won't fit. So therefore, I'm not going to put it. So I'm going to draw my line right there. And I'm going to do it again this way to make sure it lines up. That's close enough, right? And then I'm going to draw my arrows. And now this is my graph for 5x plus 4y equals 20. All right, let's go ahead and go to the next slide. So example 2. We want to graph using slope-intercept form again. So negative 20x minus 5y equals 10. This again is in standard form. We want to convert it into slope-intercept form. So how we're going to convert it to slope-intercept form? Again, we need to get that y by itself. So first we need to get that negative 5y by itself. So I'm going to add 20x to both sides. That's going to give me negative 5y equals, I'm going to put the 20x first because that lines up with your y equals mx plus b. 20x plus 10. Now, I want to get rid of this negative 5. So I'm going to divide both sides by negative 5, which means I need to divide everything on the right side by negative 5. This gives me y equals negative 4x. 20 divided by negative 5 is negative 4. And 10 divided by negative 5 is negative 2. Y equals negative 4x minus 2. So now I need to graph that. So I know my b is negative 2 and my m is negative 4 over 1. Therefore, I can start off with negative 2. Now I'm going to show you a little trick right here. I could go down 4 and to the right 1, but that's only one way. I could also go up 4. So go up 1, 2, 3, 4, and to the left 1. I go up 4, that's positive 4. But then to the right, to the left 1 would be a negative 1. So 4 divided by negative 1 is negative 4, which still lines up. So as long as you're consistent with your negatives, you're still going to get your answer. All right, so now I can graph this. See if I could make it go through all those points. That's pretty close. It's not going to be perfect, but that's all right. Connect those, make them lines, and this is your equation for slope-intercept form. Now, slope-intercept form is not the only way that we can graph using using standard form. We could also graph using the intercepts. Now, I know this seems kind of weird, but we could find our x-intercept and we could find our y-intercept. So here's how we're going to do that. To first find our x-intercept, or let's first do y-intercept. We're used to finding our b, finding our y-intercept, right? So remember, when we're finding the y-intercept, there's a height, but there is no horizontal distance left or right, right? So whenever we have our y-intercept, that's the ordered pair 0, comma, something, right? So that means x is 0. So that means we're going to do negative 15 times 0 minus 12y equals 60. Notice, that's just going to give you negative 12y equals 60. We're going to divide negative 12, divide negative 12, and y equals negative 5. So now I just found my y-intercept. But notice, if we had an x-intercept is where it crosses the x-axis. There is no height. You are perfectly flat. So if there's no height, that means our y value is 0. So what we're going to do here, we're going to do negative 15x minus 12, and we're going to plug in 0 for y. And that's going to give us 60. So that gives us negative 15x equals 60. We're going to divide negative 15, divide negative 15, and then x equals negative 4. These are our two intercepts. So let's graph them. Our first intercept is 0, comma. We can make an ordered pair, 0, comma, negative 5, which is right here. Our second one is negative 4, comma, 0, right here. And now we can graph that. So we connect the lines right here. And then we put the arrows. This is your line. We use intercepts. I did not make slope-intercept form. I didn't have to. I plugged in 0 for x. I got my y value, which is your y-intercept. I plugged in my 0 for y. I got my x value, which is my x-intercept. Once I got those two intercepts, I could graph them and get my straight line. You only need 2 points in order to graph. All right, let's do one more example of this and then call it a day. So this one is standard form. So all of these ones we've done have been standard form. So we want to graph using the intercepts. So we're going to set up that little table. And then we're going to plug in 0 for x, and we are going to plug in 0 for y. Before I even start doing anything, I'm just going to put zeros in the table. I know I need a 0 for x. I know I need a 0 for y. So first I'm going to plug in 0 for x. So look at this. I'm going to do 3x minus 7y equals 21. Now, if I'm going to plug in 0 for x, notice I could just get rid of the x because 3 times 0 is just 0. So now I know I have negative 7y equals 21. So divide by negative 7, divide by negative 7, y equals negative 3. I'm going to do that again, but with the x values or the y values. So 3x minus 7y equals 21. So now, since my y is 0, I can get rid of this part right here. Therefore, I just have 3x equals 21. So I'm going to divide 3, and then I have x equals 7. So my ordered pairs are 0, comma, negative 3, and 7, comma, 0. So 0, comma, negative 3 is your y-intercept. Your x-intercept is 7, comma, 0. Make that look a little better. 7, comma, 0 doesn't quite fit, but kind of does. So we're going to put it right there. And now I'm going to create my straight line. 1, 2, create my straight line. And we are done. I have graphed using the x-intercept and the y-intercept. All right, your homework due Friday by midnight, chapter 13.5. Remember, just do it online. If you want to send it to me, fine. It's pages 600 through 601, 2 through 26 evens. That's only 13 problems. Not too bad, guys. All right, challengers, good job with this lesson. Hopefully you guys don't struggle with homework. But remember, if you do, you can go to my office hours daily from 2 to 3 p.m. or Tuesday, Thursday during that math time period. All right, challengers, I will talk to you guys later. You guys have a great rest of your day and stay strong.